Welcome to Lecture 3 of Physics Concepts. Today, we will explore the fascinating topic of linear motion. Let's dive in and understand what linear motion is all about. First, let's define speed. Speed is how fast something moves, specifically the distance traveled per unit of time. It's a fundamental concept in understanding motion. Speed is calculated by dividing the distance traveled by the time taken. For example, when sitting on a chair, your speed is 0 relative to the Earth but 30 kilometers per second relative to the Sun. A speedometer measures speed in miles per hour or kilometers per hour. Next, we have velocity. Velocity is the speed of an object along with the specification of its direction of motion. It's a vector quantity, meaning it has both magnitude and direction. Velocity combines speed and direction. For instance, a car on a circular track may have a constant speed, but its velocity changes every instant due to the change in direction. Acceleration is the rate at which velocity changes with time. This change can be in magnitude, direction, or both. It's a crucial concept in understanding how objects move. Acceleration is calculated by dividing the change in velocity by the time interval. The greater the slope of an incline, the greater the acceleration of a ball rolling down. What happens if the incline is vertical? Free fall refers to motion under the influence of gravity only. It's a special case of motion where gravity is the sole force acting on the object. In free fall, the velocity of an object increases as it falls. The velocity acquired can be calculated using the formula v equals gt, where g is the acceleration due to gravity and t is the time of fall. The distance fallen in free fall can be calculated using the formula d equals 1/2 gt/2. This shows how far an object falls over time under the influence of gravity. The rate at which velocity changes each second is constant in free fall. This means that the velocity increases by a fixed amount every second. What happens when a feather and a coin are dropped in a vacuum versus in air? In a vacuum, both hit the bottom at the same time, but in air, the feather takes longer due to air resistance. Let's summarize the key formulas we've discussed. Speed equals distance, time. Average speed equals total distance covered, time interval. Acceleration equals change of velocity, time interval, and the formulas for free fall. Thank you for watching. Please like, share, and subscribe to this channel. Add a comment below the video to share your thoughts. What did you learn from the video? What topic would you like to explore further? This presentation contains copyrighted material used under the Fair Use Doctrine for educational, commentary, and research purposes. All rights belong to their respective copyright holders. Links are provided in the video description to relevant resources.